Hello everyone. Today we are diving into the incredible world of Claude 3.5 Sonnet, the latest and greatest from Anthropic. Not only does it outperform some of the biggest in the game, but the real game changer is its new feature called artifacts. But we are not gonna stop there. On today's tutorial, we are going to take it a step further and show you how to create your own custom tool to supercharge Claude's capabilities. So, let's get started. Welcome back everyone. I am Aat Fataya and I am passionate about making AI practical and accessible for everyone. Today we are going to unlock a whole new level of functionality with Claude. We will build two tools, a simple calculator tool to get our feet wet, and then a powerful research assistant tool that will help you gather information like a pro. So get ready to transform Claude into your personal AI powerhouse. But before we start, if you are new to Claude, I would highly recommend for you to watch my previous two videos where I will take you step by step through everything, from getting started as a beginner to explore Claude's amazing vision capabilities. All that knowledge applied to Claude 3.5 Sonnet. Now let us get started with what is Claude 3.5 Sonnet. Anthropic has recently released Claude 3.5 Sonnet, a powerful model that has outperformed GPT-4o and Gemini 1.5 Pro model in various benchmarks. Its visual reasoning is especially impressive, and you may want to include them in your development workflow. Claude 3.5 Sonnet is part of a larger Claude 3.5 family, which Anthropic will release Claude 3.5 Opus and Haiku later this year. Claude 3.5 Sonnet demonstrates noteworthy improvement in image understanding and generation, and has shown a great performance in benchmark, especially in coding and reasoning tasks compared to other models. It also introduces a new feature called artifacts for enhanced information management within the conversation. Now let's start with a demo about artifacts, and then we will turn to Jupyter Notebook to start building application using Claude 3.5 Sonnet. Alright everyone, let's explore Claude 3.5 Sonnet most exciting feature, artifact. This is not just about chatting with AI anymore, it's about collaborating with it to create amazing things. Let's start with the first prompt. I'm going to ask Claude to design a modern website homepage for a plant-based restaurant called The Verdant Table. Alright, now let's see what Claude can come up with. I'm really curious to see the website design artifact it generates. Amazing, look at that. Claude has not only designed a beautiful homepage layout, but it also included a placeholder for the images and compelling text. Notice that now we can interact with this artifact directly by making suggestions for improvement. This is where the real collaboration begins. Alright, now let's try a different prompt for design. Great, it was able to generate the mood board. Let's try another example. Perfect, it generates for us beautiful logos. Okay, and the last example. And it generates a beautiful UI. As you can see, artifacts are incredibly powerful tool. They transform your conversation with Claude into interactive work session. Whether you are designing, coding, writing, or brainstorming, artifacts can supercharge your workflow and creativity. Projects is a new feature in Claude that allow us to upload our own document, code, and files to collaborate with Claude and our team. We can create a project to chat with Claude around a set of files. This will help us organize our work and leverage knowledge across multiple conversations. This takes AI collaboration to the next level. Let's create a new project to see how this works. To create a project, click here on the top right corner, create a project. I'm going to call it my AI learning project. Same for the description. Now here I'm uploading some files I want Claude to help me with. This could be anything: research paper for summarization, code for debugging, even your creative writing for feedback. The idea is to give Claude a focused set of information to work with. Let me upload a sample document. I have uploaded a PDF document about graph neural network. I want Claude to summarize it. As you can see, Claude isn't just giving a generic answer. It's pulling information directly from the files in our project, and it was able to summarize the document. And this is just scratching the surface. Projects also offer features for organizing our work and even collaborating with our team, all within Claude interface. In this part, we are going to build a simple application to get you started with Claude 3.5 Sonnet before creating our custom tool. And as I said at the beginning, if you are new to Claude, please watch my previous two tutorials where I will take you from beginner level to advanced vision capabilities. I have explained all these steps before, like installing the required libraries, upgrading an existing library, which is very important if you want to use Claude 3.5 Sonnet, okay? And loading the environment variable. I have all the libraries installed in this Jupyter notebook, and I loaded the environment variable. Now let's create our simple application. To build our simple application, we have first to import the Anthropic and create a client. So we'll say the following: from Anthropic, import Anthropic, and then client is equal to Anthropic. Next, I'm going to create a variable for the model name, and it's equal to Claude 3.5 Sonnet. Then we are going to create the response, which is equal to client.messages.create. First parameter is the model, which is equal to model underscore name. Then the max underscore token, it's 1024 token. Then the messages, which is an array of dictionary, is equal to the first dictionary is role, user, content is hello world. Just a simple application, all right? And to print the response here, we'll say print response dot content index 0 dot text. I'm running the code, and we get the response. This means our setup is ready. Now let's try a different example with different prompt. Here, instead of hello world, let me just comment this line. Content, write a short story about the life in the moon. And I'm going to use here additional parameter, the system, which is equal to you are a creative assistant that only respond with English language. All right. Also, stop sequences is equal to the end. And the final parameter is the temperature. I'm going to set it to 0.9 for creativity. The stop sequences parameter is a list containing a single string, the end. It tells Claude to stop generating text as soon as it encounters the phrase the end in its output. The primary purpose is to prevent Claude from continuing to generate text beyond a desired point. In our case, the story will be cut off at the first instant of the end. These stop sequences can be used for various purposes. For example, limiting output lengths or creating a structure. We could use multiple subsequences to define different sections or parts of the story, and also to prevent repetition. I'm running the code, and we get our response. So that's how we can create applications using Claude 3.5 Sonnet. In the next part, we are going to start building our tools. So what is a tool in the context of Claude? Consider it a way to give Claude special abilities beyond its natural processing skills. We can define a custom function that Claude will call on to perform specific tasks, like calculations, data retrieval, and even interaction with external services. We all know that large language models struggle with number calculation. Claude recommends creating a tool for that. GPT-4o using its own tool to customize it. And if you go now and ask GPT-4o to multiply two large numbers, it will give you an accurate answer because it is using a custom tool. Then if you hover over the answer and try to change the model to GPT-4o mini, you will see that this option is disabled. And the reason for that, as you can see, GPT-4o mini does not support tool yet. Why does this matter? Well, it's like giving Claude a toolbox full of gadgets to solve a wide range of problems. It's about extending its capabilities and make it even more useful to you. We will dive into the details in this part. But first, let's start by exploring a simple calculator tool and then build the research assistant tool. To create a custom tool in Claude, we have to follow the following steps. First, we have to define the tool implementation or function, then create the tool definition, and finally provide the Claude with the tool. Let's start with a simple example, a calculator tool. This will demonstrate the basic structure of how to define a tool for Claude. Here is our calculator function. It takes three arguments: operation, which is the type of calculation to perform, add, subtract, multiply, or divide. Operand 1, the first number in the calculation, and operand 2, the second number in the calculation. The function uses a series of if, else statements to determine which operation to perform and then returns the result. We also have some error handling to prevent division by zero. I'm running the code now, and let's test the function to make sure it's working as expected. Let's say add 5 and 10. I'm running the code cell and it's working as expected. Now to make this function available to Claude, we need to define a tool object. This object tells Claude the name of the tool, its description, and the kind of input it expects. Let's start defining the tool. We are going to call it calculator tool is equal name calculator description a simple calculator that performs basic arithmetic operations. Okay. Now the input schema, input underscore schema. The input schema should match the argument of our calculator function. Let's see how. Type is object, properties. We have three properties. The first one is operation, and it is of type string. Next, we are going to define an enum for the values allowed. We have add, subtract, multiply, and divide. And finally, description. the arithmetic operation to perform. Then we have operand 1, which is of type number. Description: the first operand. Then we have operand number 2, which is also of type number, and description is the second operand. Okay, after that we have to define the required parameter. Here in this tool all the three values are required, so we'll say here required operation operand 1 and operand 2. I'm running the code cell. Now we have to provide Claude with our tool. So here we'll say from Anthropic import Anthropic, and then client is equal to Anthropic, and model underscore name is equal to Claude 3.5 Sonnet. Now we'll say response is equal to client dot messages dot create, and then here we'll say model is equal to model underscore name messages is equal to role user content multiply 1984135 by 934316. As an example, only respond with the result. Alright, after that we are going to specify the tokens. It's going to say, let's say 1024, and here we are going to define a new variable. It is tools. Tools is equal to calculator tool. Okay, and finally let's print the response and see its structure response. Alright, so the only difference here is tools, where we provide the Claude with the tool. Okay, I'm running the code cell. As you can see here, the response looks a bit different than it normally does. Specifically, I want you to pay special attention here. Here in the text blocks, as you can see, to multiply these two large numbers, I will use the calculator function. Alright, let me perform that calculation for you. So we get this message back from Claude. Alright, and in the tool use block, we have the input operation multiply operand, the number that we provided, and operand 2, the second number, and the name is calculator. And I want you to pay special attention here to this stop reason, which is tool underscore use. For example, now if we say response dot tool, no, not tool, stop reason, and we run the code, we get tool underscore use. And for example, if you want to get the content, if we say response dot content, we can see that the response content contains a list containing a tool use block, which itself contains information on the name of the tool and inputs. Alright, so with the stop underscore reason, we can see that the Claude stopped because it decided it was a time to use a tool. And in the response content, we can get the name of that tool and the input and the operation. Alright, let's see how. So to get the tool name, we'll say tool underscore name is equal to response dot content index 1 dot name, and tool underscore inputs is equal to response dot content index 1 dot input. Alright, now let's print a message. The tool name Claude wants to call is tool underscore name, and print also the inputs Claude wants to call it with our tool underscore inputs. Okay, let's run the code, and perfect. We get the tool name, which is calculator, and the inputs as well, operation, multiply, and the two operands. Okay, now let's put it all together and see how we can use this tool. Let's copy the tool definition first. I'm gonna copy this and paste it here in this code cell. And also I'm gonna copy the tool definition. Okay, I'm going to paste it here. All right, now let's define the main function. So we'll say here define prompt underscore Claude. It takes one argument, accept only one argument. And here we will say response equal to client.messages.create model is equal to model underscore name. Messages is equal to array of dictionary, role, user, content is the prompt. Okay, after that we will define the system, which is equal to the following. You have access to tools, but only use them when necessary. If a tool is not required, respond as normal. Why we are defining this system message? Because sometimes Claude tends to always use a tool when it has access to it. For example, if we ask tool about anything from the internet, it will tend to use the tool first. So we define the system message here to make sure that it will only use the tool when necessary. Okay, after that we'll define the max token. Let's say max underscore tokens equal 500, and tools is equal to calculator tool. Okay, now we will check if response.stop underscore reason, if you remember, equal to tool underscore use, which means that it will use the tool, the calculator tool. Here we'll say tool underscore use is equal to response dot content index -1. All right, and tool underscore name is equal to tool underscore use dot name, and tool underscore input is equal to tool underscore use dot input. Okay, now we'll say if tool underscore name is equal to calculator, print, let me scroll up, Claude wants to use the calculator tool. Okay, operation is equal to tool underscore input and operation. All right, and operand 1 is equal to tool underscore input operand 1. All right, and operand 2 is equal to tool input operand 2. All right, now we'll add a try catch just in case there was an error here. Result is equal to calculator operation operand 1 operand 2. Okay, and then we are going to print a message, calculation result is result. All right, and if we got an error, we'll say here except value error as error, print f error e. All right, yeah, we're done. Now if it was not a tool underscore use, the step reason, then we'll have here else print Claude did not want to use a tool. Here, I think, yeah, here I forgot the double quote. Yeah. Alright. And then print Claude responded with, and then we are going to print the response dot content at index 0 dot text. Okay. Now I'm going to run the code cell. Now let's test our tool. We'll say here prompt underscore Claude. What is 348.99 times, let's say, 34. Okay. I'm running the code cell and we get the response. Claude wants to use the calculator tool. Calculation result is 11865.66. Okay. Now let's test the calculator tool with a prompt that does not require a calculation. So we'll say here prompt underscore Claude, write a haiku about the moon. Okay. I'm running the code cell now. Perfect. Claude didn't want to use a tool and it responded normally. Alright, so that's how you can create a custom tool using Claude. In the next part, we are going to create our custom research assistant tool. Now let's build a more sophisticated tool, a research assistant. This tool will leverage Claude's language understanding and Wikipedia's vast knowledge base to create a curated reading list for any topic you are interested in. Here's the basic idea. We will give Claude a research topic. It suggests relevant Wikipedia article title. Our functions fetch those articles and save their titles and URL into a nicely formatted markdown file. This gives us a quick and easy way to start our research journey. Now you might think why we don't ask Claude directly. We could try asking Claude directly to generate a list of article URLs, but Claude is unreliable with URLs and may hallucinate article URLs. Also, legitimate article might have moved to a new URL after Claude training cutoff date. Instead, we are going to use a tool that connects to the real Wikipedia API to make this work. We will provide Claude with access to a tool that accepts a list of possible Wikipedia article title that Claude has generated but could have hallucinated. We can use this tool to search Wikipedia to find the actual Wikipedia article title and URL to ensure that the final list consists of articles that actually exist. We will then save this article URL to a markdown file for later reading. Here is what the output will look like. Each topic is a heading, followed by a list of relevant Wikipedia articles with their links. This makes it super easy to jump right into our research. The steps for creating the Research Assistant tool are the same steps that are used for creating the calculator tool. Okay, let's take a closer look at the functions that actually do the heavy lifting for our Research Assistant. The first one, called Generate Wikipedia Reading List, takes the research topic and a list of article titles suggested by Claude. Its goal, to find the actual Wikipedia article and turn them into neat little reference for us. Here's how it works. Iterate through title, it goes through each suggested article title one by one. And then it will search for Wikipedia. It uses Wikipedia.search function to find articles that match the title. Then it takes the top search result, usually by the most relevant one, and tries to fetch the Wikipedia page. Then if it finds the page, it grabs the title and the URL. And finally, it stores this information in a dictionary and adds it to our Wikipedia articles here. At the end of this loop, we have a list of dictionaries, each containing a valid Wikipedia article titles and URL. Now this next function, add to research reading file, takes that list of articles and does something really handy. It writes them to a markdown file for us. First, it opens a file called research_reading.md in append mode, so it adds to the end without erasing previous content. Then it creates a heading using the research topic and it loops through each article and write it as clickable link in Markdown format. Finally, it adds blank line between different topic sections to keep things organized. Now, whenever we use our get search help function, the result will be automatically saved in this Markdown file for easy reference. Now let's have a closer look at the research tool definition. The name is generate Wikipedia reading list, and the description generate a list of Wikipedia articles relevant to a research topic. And the input schema is of type object, of course. Properties, we have research topic and article titles. The research topic is of type string, and it is the topic to research. And the article titles is of type array, and the description is title of the relevant Wikipedia articles. Both of these are required. Now let's put it all together as we did in the calculator tool. Here we have the function definition and the tool definition. And here's our main function, get research help. It takes a topic and the number of article required, and the default value is 3. And the prompt is, I need your help generating research on the topic of and the argument topic. Please generate the number of article relevant Wikipedia article title for me. And here's the same code as we did before. The model is the model name, and system as we did before, talking 500, and tool is the research tool. And the rest is the same as before. For example, here response.stop_reason is equal to tool_use. I'm running the code cell now, and let's test it out. Here is the research_reading markdown file. It's empty. So we'll say here get_research help, and then we'll say here are animals conscious. I'm running the code cell, and it is done. Let's check the file. And as you can see here, we get 2 articles, are animal conscious, animal consciousness and animal consciousness. Let me just copy the URL and make sure that this URL is working. And here is the research article, animal consciousness. Alright, so everything is working fine as expected. Now let's try another example. Get_research help pirates across the world. Alright, I'm running the code cell, and it is done. Let's check the markdown file again. As you can see, we get 3 articles here. Let me copy one of these URL. I'm gonna copy this one. And here is the article, Golden Age of Piracy. So that's how you can create a custom research tool using Claude 3.5 Sonnet. I'm going to leave a link in the description of this tutorial for this Jupyter notebook for you to download it from my GitHub account. Alright everyone, that's a wrap up on our tutorial on creating tools with Claude 3.5 Sonnet. We have covered a lot of ground, from understanding the basics to building advanced research assistant tool. Remember, this is just a starting point. The possibilities are endless when you combine the power of Claude with your own custom tool. I encourage you to experiment, explore, and build something awesome. At the end, if you enjoyed this tutorial and want to learn more about Claude, be sure to hit the like button, subscribe to my channel, and ring the notification bell. Until next time, happy coding!